Okay, so now that we understand what an exponential function kind of looks like and we've identified some key features, let's graph some that might have some transformations. So we're going to graph those and compare our functions to the parent function f of x equals 3 raised to the x power. How do the asymptote and intercept of the given function compare to the asymptote and intercept of the parent function? One thing I just want to make sure we're understanding, if our base is 3 and we're raising it to different powers, what we're looking at is 3 to the first power, 3 to the second, 3 to the third. So we're basically, if your base is a 3, we're multiplying 3's. How many 3's are we multiplying? That's what that x is. That's why it's increasing so quickly. Exponentially it's increasing. But just want to make sure we are connecting the fact the math of these functions is multiplying that base over and over, however many times your value of x is. Okay, anyway, what I would like to do is graph the parent function, f of x equals 3 to the x power, and then graph this transformation, just so we can compare and see. So the parent function, I'm going to write up here. I'm going to write it where I have the a and the b value. So 3 to the x power, 3 is the base of your exponent of x, so that is your b. So our a value must be a 1. 1 times 3 raised to the x power. That's the parent function. If you remember in the last video, we said that our a value was also the y-intercept. So the parent function has a y-intercept at 1. And then you can kind of think through a couple other points on here. 3 raised to the first power. Well, when x is a 1, what's 3 to the first power? 3 to the first power is 3, times 1 is just 3. So another ordered pair on our parent function, when our x was a 1, we just said the y would be a 3. What if your x is 2? 3 squared is 9, times 1 is 9. I don't even think I can fit 9 in here. 1, 2, 3, 4, 5, 6, 7. I suppose I could say, well, 9 is about there. So you can see how we're increasing quickly. So the parent function, just kind of sketched out, is going to, here's our curve. It's going to come down. And without any vertical shifting, it's just going to curve down and head toward that x-axis. So any thoughts on what a negative 3 to the x power is going to do? What kind of transformation that is? So again, let's rewrite that so we recognize g of x equals, that is a negative 1 times 3 to the x power. All right, so when you're multiplying your function by a negative number, that is going to be a reflection across the x-axis. So we can take all of our points that we plotted, I guess we only plotted a couple of them or a few of them, and we can reflect those down and get an idea of what this graph is going to look like. So our y-intercept is going to be in a negative 1, and then we had a point that was 3 above the x-axis, now it's going to be 3 below. It's going to look like that. And I know we're coming in, hugging the x-axis. We're going to go through this point, and we're going to steeply decrease like that. So there is our g of x function. The negative out front reflected it across the x-axis, and it says compare the asymptote and the y-intercept. So the y-intercept changed. It went from a positive 1 to a negative 1, so it reflected that down, but the asymptote did not change. And I've been saying your asymptote will change if you have a vertical shift. So the asymptote is the same, but the y-intercept did shift down. Okay, now let's take a look at our next function, h of x. So here's 3 to the x power. There's our parent function, but we're subtracting a 4 on the end. So what do you think the 4 on the end is going to do? I mean, you guys already know this stuff, right? We are going to have a vertical translation down 4 units. So I am just going to plot a couple of those points from the parent function. We had 0, 1, and we had 1, 3. And remember, our asymptote was at y equals 0. So everything's going to shift down 4 units. I actually am going to draw in the asymptote this time because we don't have an axis to use. So I'm going to go down 4. Here's my new asymptote at y equals -4. And then our points are going to shift down down 4 units. So if I shift down 4 units, I'm up here, I go down 1, 2, 3, 4. That's going to be our new y-intercept. And then the other one is going to go down 4 units and end up right there. So we can draw in our new graph. Remember, it goes along the asymptote, goes through these points, and it has a sharp increase right there. So how do the y-intercept and the asymptote change? Maybe we'll write this one in. How does it compare to the original, the parent function? The y-intercept and asymptote shift down 4 units. So those will change with your vertical shifting.